Hi everyone, welcome to Code Viento. We are solving 202 happy numbers together. Repeated digit squares. Sounds like a hidden cycle waiting to happen. We are not just checking numbers, we are checking for loops. Let's detect cycle with a set, or even better, 2 pointers, fast and slow. Write an algorithm to determine if a number n is a happy number. A happy number is a number that will eventually reach 1 after repeatedly replacing the number by the sum of the sequence of its digits. If it loops endlessly in a cycle that does not include 1, it's not a happy number. Let's check the first example together. N is equal to 19. The sum of the squares of the 19 is 82. The sum of the digits of the 82 squares is equal to 68. The sum of the 68 squares of the digits is equal 100. The 100 digit squares is equal 1 square plus 0 square plus 0 square is equal 1, and it's an happy number. Let's check the second example together. N is equal to 2 square is equal 4. 4 square is equal 16. Sum of the 16 digit square is equal 37. Sum of the 37th digit square is equal 58, and the result for the 58 is equal 89. The result of the 89 is equal 145. For the 145, the result is 42. For the 42, the result is 20. Sum of the sequence of the digits 20 is equal 4. There is a loop and we don't have 1 as a result. Let's check the code together. We will define slow and fast pointers. And the fast pointer for the next step of the digit square sum. While fast not equal 1 and slow not equal fast, calculate the slow and fast pointer. Slow moves 1 step. Calculate the digit of the sequence sum. Fast move 2 steps. Digit of the sequence sum and the result digit of the sequence sum. At the end of the loop, if fast is equal 1, it's a happy number. Let's run the code together. Tests are accepted. Let's submit the solution together. Our solution is here. This problem isn't about digits. It's about cycles. You either reach 1 or loop forever. And once you see that, you know exactly which pattern to apply. Fast and slow. Time complexity is O(n), space complexity is O(1). If you found this video useful, don't forget to like and subscribe. Thank you for watching, friends. See you in the next one.